Okay, this is the last video for this section. What is it, 7.3? And on this is a completely different topic. It's solving equations with rational expressions, but I think these are solving equations with rational expressions we did in chapter 5, but on these, when you simplify things down, you end up getting a quadratic. So that's the relationship with the rest of this section. So the first thing you do is you clear the fractions by multiplying each term on the left and right side of the equation by the least common denominator. And if you don't know what we're doing this to yet, I'll show you in a minute. You have fractions, you clear the fractions, multiply by the LCD for every term. So here's an example, right? That's a equation with rational expressions. It's actually usually called a rational equation. Okay, not radical, that would be square roots. Rational ratios. Okay, but it's not one of the simple ones that it's a proportion. Proportion would just be only one of these two terms on the left equal to the thing on the right, you know. Okay, so the least common denominator, probably this factors is this times this, but I would write it down and check it. I can kind of see it works. Well, I could definitely see it works, but I'm going to factor. And what I did is I factored the numerator as well. And the reason I factored the numerator is just because I wanted to see if it reduced. Now, you could do that in your head and see if it reduced. It doesn't. But so maybe it's not worthwhile to factor the numerator there. If it reduced, then maybe it helps. In this case, it really wouldn't have helped either way. I don't know why I did that. So I'm just going to write down what the LCD is. This is a smart thing to do. Write it down just like this. And then you're going to take that LCD and you're going to write out everything in the equation and just put times that in the numerator of each one. Okay? And of course you'll need parentheses on if the numerator has a binomial already. Right. See? That's the LCD in red there. Right? Just all the way across. Each term gets one of those in the numerator. Not numerator, denominator. I have an equation, so I don't have to do numerator, denominator business. Right? I just clear the fractions so I don't have to deal with fractions. So those two cancel. Those two cancel. Those two cancel. Those two cancel. And you'll notice there's no denominators left. Yay. Except for one. The number 1. Okay, so what did I do here? X plus 1 times x minus 2. I just multiplied them out. It gave me that. And then I'm going to multiply the 2x minus 1 times the x plus 3. And I get that. Equals. And then I just multiplied the 2 times the quantity 6x minus 1. I multiplied them out, but notice back here, it was already like that, and I factored it for absolutely no reason, and then multiplied it out again at the end. That's perfectly fine. It's not wrong. It's kind of a waste of time, but if, you know, it's the kind of thing a lot of students might do, just as I might, which I did. It's no big deal. You can multiply it. You can distribute the 2. It's just usually you don't factor things unless you have a reason, and I just factored it without really having a reason. Not perfect. Definitely not perfect. Okay, combine all the like terms and get all the non-zero terms on the left. Correct? And I look at that and I think, well, if I did the AC method, I'd have -9. That means I need 2 factors whose difference is -8, or whose sum is -8. So it would be -9 and 1. So I could factor that by grouping. Therefore, I'm by the AC method. So I know I can factor it. So I just factored it. And you can use whatever method you want to factor it. I didn't write out all the steps because you're supposed to know that already. You're supposed to know how to do that. Go back and review chapter 4 if you don't remember. Okay, and all this stuff you should know actually from previous courses. So that's the first one is negative 1/3, and the second one is 3. You know, I want to check those. So this is how I usually do the check, right? I do x equals 3, colon, underline. And when I don't do that, I mess it up. That's why I do it. Okay, so 15. Wait, what's going on here? Oh, that says left side, LS. The left side, I just plugged 3 in, and I got that. And then I simplify it. Da 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 da. For me, it's a little easier to write that out on paper than it is to put it in a calculator. If you can more reliably put it in a calculator, just do that. Right? Whatever is more reliable for you. So you notice those two matched. I did the left side of the original equation here. And then I did the right side, and I got the same number, 17/3. That's just checking x is a 3. That's why it's important to write this down, because I spent a while on it. And then you would want to check the other one, which was negative 1/3, which I didn't write out, but you can do it. You just maybe use a calculator on it. Okay? So be careful checking these, because there's look how many times x was in the original equation. You had 1, 2, 3, 4, 5, 6, 7 times. So it's pretty easy to mess that up, especially with negative 1/3. So be very careful checking your answers. And if they don't come out correct, then try to check them again before you go back and find a mistake in your algebra. Okay, that's it for that section.